Kenntnisse, wie viel der TouchBar es ist?
So,
Okay, wie viel die TouchBar ist? 8.
das ist die 8. Insofern sollte ich das hier mal lieber ganz schnell ändern. So. Da brauchst du jetzt einen Monat. Na gut. Sagen, das was zu trinken sein.
Jo. Kommt drauf an. Kaffee? Ja. Da bin ich dabei. Ach so, du. Online müsste ich, glaube ich, auch noch gehen. Hi. SUW Guest.
Genau. Und dann Passwort ist Spinner und Über.
Klein. So ein guter Facebook-Name.
Ich glaube schon, du hast mich mal, glaube ich, David glaube ich auch. Entschuldigung, bleibt dabei.
So, ich hier drin. Ja, okay, ich kann da nicht ins Internet. Das sollten wir noch schnell klären. Was ist mit dem intern?
Hat es nicht funktioniert?
Nee, mit Gast nicht, ne?
Dann läuft es. Und dann genau und lieber alles klein und zusammen.
Jetzt geht's.
Okay.
Das ist heute der Tag des zweiten Versuchs. Das Berlin ist auch nicht so groß, wie man manchmal denkt, ne? Hast du noch so eine Art Vorspann und so?
Nö, wir sind schon live.
Wir sind schon live, oh mein Gott. Dann müssen wir jetzt auch Englisch sprechen, oder?
Ja.
Willst du noch einleitende Worte sagen?
Einleitende Worte.
Okay, willst nicht.
Yeah, welcome to TouchBar number 8. This time with a live stream. Straight out of Berlin, the nice wedding. And today we have our longtime guest and speaker Stefan Kraus of MXZEHN, and he will talk about the following topics.
Yeah, hello everybody. Live here from Berlin, we're at the TouchBar where the big Berlin touch designer crowd has gathered tonight. And well, I used the opportunity to talk a bit about what I was busy with the last months, mainly talk about what I learned from that and like to share, because the rest is not so spectacular. I was working with a company called Mono Mango. They produce interactive and non-interactive media for brands, and when I have time also for friends. Yeah, and we work together on 2 projects. I mean, you can look at their website. They're in general very nice people, and they make amazing work for major brands like Mercedes and Google and IBM and others. And I worked for them on 2 projects together with many other people. One of them was for IBM. It was like a projection mapping of the so-called intelligent building, which was about data visualization. And there I worked mainly with Juan Duarte, who was also developing touch designer and open frameworks. Abe Pazos, who was developing open frameworks, and Ingo Randolph, who helped us a lot to figure out the control situation. The next project was for Google, the launch of the Pixel 3, which was launched in 3 pop-up stores in 3 major German cities, Hamburg, Berlin and Munich. And as it was very short-term and it was a big project and there were these many locations, I had the privilege to work with the whole all-star team of Andreas Schmelas, Daniel Delfofo, Itaru Yasuda, Klaus Helfenschneider, Ingo Randolph, and David Leroy, which I forgot in that list, and many other people, but these are the main contributors to the software, which I will talk about later. Then I would like to talk a little bit about the thing that pleases me at the moment the most, which is working on visualizing Bach works, or playing with the MIDI of Bach works. And last but not least, I would like to mention the Touch Designer Beginners and Advanced workshop that we will hold on the 14th and 15th of December in Berlin, I hear there's still tickets available. Let's dive right into it. Monomango is made up of Lois, Jan and Olivier. And, I've been working mainly with Lois, who is like the creative director. And let me show you maybe a few pictures. Project was really tight, so actually I didn't make many pictures. There might be documentation somewhere soon. However, it was quite pleasing to work in that shiny building here in Munich. And there where the second bridge is visible, that's where there's an exhibition floor. And you see a model of the building designed by Tim Stolzenburg from Monomango. And you see like a misplaced mapping on that. And that is basically in this exhibition, there's like an iPad visible, and that was used to trigger videos and to play with interactive data visualizations. That's the view from up there, and that's how it looks, part of it at night. So what was there to learn? The first thing that made us really sweat was the media player. So you might think, okay, we have data visualizations, we got lots of JSON packages of complicated temperature and humidity data and so on. We want to make them in 3D shapes and stuff. So yeah, Touch Designer makes that happen in 3 days or 4 days, and it's not really breaking your head too much. Juan was doing great work with the raw data, and I could take it and turn it into animations quite easily. But what was really kind of difficult was to create a media player that would show the pre-rendered animations on the building. And the difficulty was mainly that we wanted to fade from one medium to the other, which in the afterthought was maybe not a good idea because fading wasn't so necessary, but that made everything very complicated because you need to have an A/B player which checks the states, what is going on, and so on. And in the end, we had to get help from Markus Heckmann from Derivative, who taught us a few tricks, and is not to underestimate how much effort actually such a media player can make, which is everything else was kind of easy in comparison. I'd like to show you a few pictures from the documentation. So basically the installation was run on 2 computers. One would make the projections, would run 2 projectors, which were the building, and one would run 2 projectors who projected the floor. Very nice Panasonic laser projectors, which you can just leave on. So they run 24/7. There's no more need to switch them off officially, which feels a bit weird if you leave in the night. Just leave the projectors on, come back, they're still running, everything's fine. So that was cool. One thing we learned is, because I came in a bit later to the project, and like everybody who was working there had a really hard time to map it for months. And in the end, it turned out that they're ready before when they installed the projectors. Which were very professionally installed, so you wouldn't think that there could be anything wrong. Somebody had worked with the keystone in a very hidden, very evil black magic part of the keystone engine of that Panasonic. So you wouldn't see it on the first look. So nothing worked properly, and there was no reasonable explanation. And in the end, we found out, well, somebody changed the projector. So lesson learned is, whatever projector you're trying to map with, first reset it, everything back to 0, no matter what had happened before. If somebody tells you, technician, he already made it good, reset it. Because if you want to do something like Kammschnapper and anything has been keystoned with a projector, it will just not work. What else was there to learn? This is a bit like the structure of the project, so we tried to work in components, not as successful yet as with the second project, and the reason is that in the second project we work with GitHub, and GitHub makes it so much easier to work together with several people and to distribute stuff on several machines, so it's highly recommended to use GitHub. I'm looking for something specific. Yeah, in the end, the code necessary to make the media player, let's say half of the code was that. That was something that I didn't really expect. So there's so many exceptions, and because we had, the users could go for a play all mode, which plays all through the playlist. They could jump to single chapters. There is previous and next buttons, all very simple stuff we all very used to do. But then if you need to make it work with OSC and Touch Designer, it suddenly can turn into something quite difficult. One thing we had to learn, for example, is that OSC, which everybody likes to work with, is actually not such a good idea for these kind of projects. It's very easy to use because of the path situation description, but usually OSC is broadcasted over UDP, and that can have packet loss. And there we had a situation where we had 3 iPads, which would be able to control the media on the sculpture. But that also means that the state of the iPads needs to be updated, so there's bidirectional communication. And as soon as one of those packages, which are basically just has the button being pressed or not, gets lost, like everything gets out of rhythm. Users start pushing too often, you get too many signals, like the logic isn't right anymore, and so on. So that can really be a problem. And what I think after that is that this was actually the perfect situation to work with MQTT, because MQTT works with a broker who gets all the messages and then distributes them to clients which can basically make an abonnement to certain topics. That means that your sculpture may only get the information that the sculpture needs, the media player. The iPads get only the information that the iPads get, and the broker makes sure that every message that has been sent will also be distributed to all the different clients. The price for that is probably that you have to set up your own MQTT server if you don't want to do it over the internet, which was also challenging with IBM because you're actually in a big server room, but you don't have internet because the server room is not on the internet, and which makes then remote controlling an installation or any change very difficult because you basically have to go there to do it there. But on that scale, it would not be a problem to install your own MQTT server. And I prepared a little example for MQTT because I had to figure it out for myself for quite a while, how it actually works. And so I thought I'd share that, and we can put it on the Berlin site so people can download it, play with it. And let's see if we can make this work. So this is the MQTT talks. You can't see my screen. Like following. wertvoller Hinweis aus der Regie. Dupliziert, yeah, perfectly. That's what I was looking for. So, how does this work? Here's a few information that you need to make a connection. First of all, you need a broker, and a broker is basically a web server. And there's this one here, broker.hivemq.com, which you can use as a test broker. So this is quite nice. Here again is the address, and then basically this is just broking everything that people publicly serve to it. And the way MQTT is organized is that you need to define a topic. Under the topic you can have all kinds of other stuff happening, and then clients can, what they call it, subscribe to the topic, and as soon as you subscribe to the topic you get the information in. So what we're going to do is we're going to try to take this noise value, a local noise, and send it over MQTT on the server, get it back from the server, and see how both of them compare. So at the moment this is our local noise, and that is what comes from the broker because we're not connected yet. And this is a little thing that I built to see if we have latency. So the circle scaled by the noise, and the green one is the local one, the red one is the broker, and basically if we don't have any loss or time loss, we never would see the red one. At the moment we see it because we're not connected. So here I made a few scripts with which we can subscribe or unsubscribe to the server. The main node in here is the MQTT client, is here, and basically it wants to know who's the broker. That's this address that we've seen before. And then we could say connect, and well, to see if that works, it's good to have a text port open.
But do you have to use the hivemq.com broker, or could you set up something local?
You could set up something local, as far as I understand. The thing is, you have to set it up like a web server, and it's not my line of expertise. And it might be that the software to set it up is not really free. Okay. After a certain kind of client, so it's more is used a lot in this Internet of Things and more in the professional market. So I think that's why. But I didn't look into that side. So for testing, this stuff here is free. But sure, if you want to make an installation, you have to have it local. However, the advantage would be you could run it through the Internet, so you could control several devices on different locations over the Internet with an MQTT server, and then I guess you would have to pay a bit to the people who run the server. Also, if you use this one, everything you send over it is public. So to get this info here, I went into the callbacks, and basically dumbly just wrote in here when the onConnect case happens, print connect, and so on, connection lost, subscribe. And when it's publishing, it's also writing, so this moment is already publishing, but basically the way would be to run this script and to say we want to subscribe. So here I make a variable with the MQTT client, and this variable I say the MQTT client should subscribe to the topic MXZEHN. These commands are easily found here in the Python help of this object. So basically here you find firstly explained how this all works and what commands are there. So we just use the subscribe to a certain topic. There's also always this QoS value, which is quality of service, which means something like the higher it is, the more effort will be made to definitely get this message across. It's a bit more complicated than that, but that's what I remembered. For us, maybe not so important at the moment. So here we subscribe to MXZEHN now. That means we should get incoming from MXZEHN when MXZEHN sends. You can also, one way you can test with a string, because the thing is, what made me think a bit is, so if you publish something, first of all you say under a topic, so in that case again is MXZEHN, it has to be a string. And then about the second message, all you can read is it says it should be binary. Or I didn't really find how to convert stuff from string to binary or whatever, but I saw that there's like a little b in front of a string, and that seems to be enough to turn this, to send this over MQTT. If you don't have that b and the message in brackets, in these marks, it doesn't happen. Don't ask me why. So there's somebody with more computer knowledge probably could explain that. So what I had to do is to take this value and turn it into a message that would actually come through. And so how I did that was here by saying, well, I have a B, and then I add these quotes, in quotes, plus a string, which is here the rounded value, plus again the quotes in quotes. And this has to be evaluated here, and then it works. So not 100% sure how and why, but somehow that's how it works, and that's why if you download the example, it will probably work for you. At the moment there seems to be a problem, which I didn't have at home, so I'm not sure. It still doesn't work perfectly yet. Probably has to do with this error message.
Did you execute the subscribe that?
Yeah, I'm gonna run all of them just now. Yeah, basically I published all of them, but we have no incoming. But I think when we look here, I mean, if you broadcast enough, you show up here at some point. Here is everybody who's testing at the moment. And when you send enough values, your name will start filling this here. But at the moment, I'm not sure. I think that we're sending because it says publish and no error messages. But somehow we don't receive. That's unfortunate. I think I will not really figure out immediately right now what's wrong. So maybe let's leave it that. With this example, everybody should be able to make it work. Let's just forget about it now. However, it's definitely a lot of fun when it works. So that's that. The next thing that I wanted to talk about was the Google project, where we had that nice all-star team, where it was much more necessary to also work with GitHub, because there were lots of developers involved, but none of them all the time. Because, well, Itaro had to fly to South America for a week, and so back and forth. Everybody could only work at separated times. So it's very necessary to have a structure where people can upload their changes, other people can download them, and the whole thing is organized. what was also nice in that project, let's see if I can find a few pictures. Yeah, so basically there were two main installations. The one was a big box in which people could start a show by a voice command through Google and then take selfies in the box with an animated background, which would react to the movement of the mobile phone, and then when you went out, you would get an automatically made collage from the pictures taken inside the box and that could be printed on a photo printer. Again, there's not too many great photos that I have, but yeah. And the other installation was this kind of sushi band where objects would drive around the stand, and on these screens you could see animations of the objects, like they would drive into the tunnel and then something augmented reality style would happen with them on the screen, and on the other screen they would give you a call to action to scan them with the Google phones that people were handed out, because there's this lens function where you can get information about objects. So people should take pictures of these objects and see then what they are. The way it functioned here was that on every of that little objects on the bottom there's an RFID chip. These RFID can be written any better mobile phone, for example the Pixel phone. So you give them an ID, and here in front of these tunnels there were RFID reader, which are basically Arduino boards that would recognize the chip and send the chip of the ID to Touch Designer. So that way Touch Designer always would know, okay, there's object 4 coming or object 5 coming. So that would trigger the animations shown on the screens. Fortunately here I was smart enough to think that we don't need to fade stuff into each other, which was very helpful. And also with the last installation I was still thinking we need a playlist, because then we can dynamically change the playlist, which will probably never happen. So there's like all this great dynamic playlist thing, but well, you don't use it. Here I thought, well, we have only shown so many clips. Basically we can load all the clips into Touch Designer and just trigger them. That way you don't have to bother with the whole loading it from hard disk blah 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 stuff, because all the films are there all the time. It's so much easier to handle, and if you just have like 20-second clips, you can have a lot of clips in memory or basically at hands in the patch, and don't worry about the whole loading from hard disk. Yeah, here's another picture of that box, and here in the right you see Klaus testing the phones, and so people could place their phone on a marker here, and that would cause the program that run the printer to print the image. Let's see if I have an example. Yeah, and the challenge was also, this was all happening very short-term, in 3 consecutive days in 3 German cities with partly the same team. And so every delay pushed back towards Munich, which was the last location, and so that was like how Munich looked one day before the opening. So that was pretty tight. This is basically how the photo montage looked like. Let's see, so this is one that we took in Munich privately, anonymously basically. And there was great work done by Daniel Del Fofo and also Klaus Helfenschneider, who figured out, and Andreas Schmelers, because to make these collages sounds quite easy at first, but then you realize, well, people can make all kinds of resolutions with these phones. A picture could be square, it could be horizontal, it could be landscape, it could be this, it could be that, it could be that. And you don't want to crop too much, because people see the image in the preview, so if you crop, you get their heads off or something. That's not an option. So there had to be a way programmed from the phone knowing which orientation an image has. Because also when people move around with the phones, it could happen you have a landscape photo, but it shows something horizontal. and so on. So basically, suddenly there were like all kinds of options, and they figured out a way to know what kind of image comes in which orientation, and then building algorithms who would arrange these images, no matter if they're square or landscape or whatever comes along, into a pleasing order. Now, can't tell you how exactly they did it because I didn't work on it, but in the end it worked quite elegantly. Whatever constellation people were taking pictures of, they would be in a nice collage, and that was all done by TouchDesigner. That would then save out a high-resolution TIFF image for the photo printer, and a lower-resolution JPEG image, which would be sent via email to the user. All of that was happening on basically lockdown phones, which were in kiosk mode, so they only show what you want them to show, and so you can give the user a guided experience. So they get the phone at the beginning, they have to give their email address, so you can send them the picture later. They can also not do it if they don't want the picture. But then why do you go in a Google photo booth if you don't want an email with a picture? Yeah, and then afterwards they got told, okay, now you have to give the phone, you have to put the phone there to get the print, and so on. And apart from little hiccups here and there, it worked quite stable. And with this project we had the big advantage, and because it was 3 locations, it was quite necessary that we had full access to remote control, to remote desktop into each computer at every location, which were like, I don't know, a lot at the end. At least 3 computers per location that we could log into. And that made it so much easier to troubleshoot, because every team member basically could go onto the computer in every city and make changes. And we tried quite a few different things, and there's like free software to remote VNC into a computer, but I would say forget it. If you really want to do it properly, do it with TeamViewer. That's the only thing that actually works with TouchDesigner, multi-screen, etc. pp. And for non-commercial work it's free, so clearly this wasn't, so we got like, had to get a big license, which was also not cheap, but it definitely worth the money. And from everything I saw with the free versions from Google or VNC Ultra and so on, they all can't really deal with this. I have several monitors, one of them is OpenGL accelerated and so on. So it may still work nicely in your local network, but on location it is just gone. There were a few things, nice things that happened during that project, most of them written by other people. I mentioned them anyway. So the path from one interesting path was people could say a command to a Google HomePod, speech recognition. So you could say, Google, starte die Show. And that would be recognized by Google on a website that would call an action on if this then that.com, from where it could trigger an action on push-to-run.com, which then could run a bot on the local computer, which then could again say something to TouchDesigner. There was also like a Node.js server involved who could then talk back to the phones. So I didn't understand half of it, but Andreas Schmielers was very good in this stuff, and also Klaus Helfenschneider, and they made this part of stuff work, and the whole Google to TouchDesigner path was paved by Daniel Del Fofo, and in the end it worked quite nicely. And what I took from that is that it's quite cool if you can connect the web with TouchDesigner and back, because that gives you a lot of possibilities of interaction with people who have mobile phones, which are very powerful devices. So it's very nice to hook up like that. Also nice software for Android phones is Automate, which can also help you to make like low-level stuff happening on phones without writing Android. And also very recommended is this tutorial by Matthew Reagan, where he explains how they use GitHub with TouchDesigner at Obscura Digital. And basically what I took from that, he explains it much nicer, is that you basically have only one main patch anymore, so you don't save lots of different tow files. You have one master tow, which you basically don't even have to save anymore when you initialized it properly. And then you would work with tox. Which is anyway recommended to work with components if you work with several people. And it also makes your programs much clearer if you think of every unit as one defined component, which can be externalized. And the process works a little bit like that. So you would have your tox, your container. You would have to tell it that is an external tox. You should turn off reload tox on start, and now you have to save the tow so it knows this is here. And then I think you have to reinitialize this and save again. So a bit of saving back and forth, and now you have this tow file which knows that there is this tox inside, which it should load from this external path. And from now on, you don't have to save the tow anymore, because everything you do will be happening in different toxes. And that's the thing that you can upload to GitHub. One thing that is very useful, as I found, is if you have a little script that you can still Control S or have some shortcut combination which will save your mother tow and the toxes at the same time, because otherwise it's easy forgotten. And for that I also made a little component which is somewhere on GitHub. I don't know. Shit, no, it's actually in the palette. But I will try to make it downloadable. Where's the bloody palette? Yeah. Tox saver. So what that does is basically if you press Ctrl Alt S, it will save the project. Well, here you have to input your individual name, obviously with a proper component that would be a custom parameter, and say save external tox is true. So that's the important. So if you copy that into a project, whenever you go Control Alt S, it will save the mother touch file and every tox in there into the respective path. And on GitHub, so GitHub has like a nice desktop browser. You would have, for example, your project with a lot of tox files or other things, and then you can say, I don't want to trash anything. Wait, let's take. It's not good. Yeah, so here you would see the history, and here if you have made any changes, stuff would show up here. You give it a title and a little description and commit it to the master. And if you want to get something from GitHub, you fetch it. So basically you, instead of saving, you save, you push your data onto GitHub, and the next time you start working, you pull them and then you start working. So that way, if in the meantime somebody did something, you will always have the refreshed files. Second advantage is you have a backup of your thing. And the third advantage, I can easily distribute it, so I can just pull it to several computers. Somebody makes changes on the central file. All the clients pull their Touch Designer versions, and again, all locations have the same program, which could be otherwise a lot of organization. I'm pretty sure I explained that really bad. That's why you should go to Matthew Reagan, who explains it really good. So the last topic I want to talk about today is the one that I really like to talk about, because at the moment have some time to do some experimental work for a festival show next year, and it's going to be dealing with Johann Sebastian Bach, the composer. And we work together with Professor Bossert, who found interesting number patterns in the work of Bach. So basically a work that stretches over 20 years, and he found relations between different numbers stretching over that whole work, encoding messages, basically, kind of like the Da Vinci Code situation. And let me show you some of that. Organized project. This is just at the beginning. Yeah, so basically there's a lot of this kind of number magic. And the thing is now that we should work together and try to visualize these theories. As you can think, that's crazy much, because that person has spent their whole life to understand this stuff and to be even capable of coming up with these theories and finding all these numbers in thousands and 10,000s of notes. Mathematics like this. So this is basically the number code for his name, because these are you see, it becomes this very own kind of mathematic. So what I'm trying right now is to link up this mathematic with then Bach notes, which I can pull from the internet as MIDI files, and then try to find if there's any connection. And what has been quite fun is basically to build, so that's my first step, to understand, or to have a look, my way of look, a machine look on the data, was to be able to visualize the MIDI even, or to be able to address like a certain time, a certain part in the piece. And so there's this one, which is rather big. Oh, wait, I have to make this proper so you can see it right. Das mit dem Ctrl P, kann man das auch wieder rückgängig machen? Auch wieder mit Ctrl P, oder was? Ja.
Nee, nicht Control, sondern Windows-Taste.
Windows P. I can also imagine that this makes a bit mad in the head if you listen to this for a few days. Actually, this is a piece for opera, no, for organ, so that's why it sounds a bit strange with this piano in the back. So let's see. Good. So the idea is a bit that these points on the bottom, these single points, I'm not sure what they are. I have to still get rid of them. They're more like error artifacts. The actual notes I'm looking at are the ones up there, which are more regular, the white dots. and the green and the red and the blue line, they're basically going through the notes, and it's the three, how do you say in English, voices. So 3 voices, I don't know, I'm not a musician, but it could be like 3 instruments, no? The piano, the trumpet, and the and on the organ, that's 3 voices. So basically up here the notes are just followed through like snakes. The lines go through follow the playhead, and this is an experiment where I took the values of the 3 voices and made them X, Y, Z points. So every new note creates a point, and here this object only appears when all voices are played at the same time, because only then you have X, Y, Z values, and then they start creating that. Let's look a bit at it. I mean, this piano roll view is relatively easy to understand. That's what you know from every music software. But I find this other object quite nice, which is very cryptic. This is definitely not something Bach intended, but it's definitely something that you can easily read out of his data. I think for the show this will be a nice contrast, this very educated, I thought about this for 20 years, view of the Bach researcher who really understands music, and then my kind of stupid view who just looks at the sheer numbers, like, oh, this could be RGB, it's like 3 values, and looks at it as more a bit like artificial intelligence who has no idea of history but just looks at the data, and will also come to meaning at a certain point, I'm pretty sure, because you can also, if you work like that with the data, you can also see how the person was programming, composing. There's like a few nice parts. I see, now we don't see it because we're rendering in too high resolution for this output. Just a moment. Okay, so maybe it's more interesting if I show you the network, because it's still at the beginning, so this is not a work yet, this is just something to experiment with. Again, one of those cases where the window is still there, even so I deleted the node for it. Okay. So basically what happens is here I read the MIDI in, and it took me quite a while to figure out, because you always see like lots of empty channels, which is because it imports basically every possible channel. So first thing to get rid of is the simplified output. I mean, that's helpful if you want to see something definitely, but you don't know yet what's going on. But then if you want to address really precisely channels, you have to turn that off. I read the whole MIDI file, which will give me all the notes over all the time. These are at the 60 frames that I'm working, these are 21,195 frames. So, and for every frame I basically have a sample, and these samples can either be -1, which they are if no note should be played, or they can be a value between 0 and 127, or in this case I think is normalized to 0 to 1. So here you can say how many channels it shows you. So at the beginning it's probably good to make as much as possible, and to that you also should go here. This is pre-locked to 60, so you only would see if node 60 is happening. If you want to see what nodes are actually in there, you could go for star. That would show you all the nodes. That will take a bit of processing power. Then you can go through and can look, well, at which channels is actually something happening. I happen to know that here the only nodes which are used are between 44 and between 40 and 84. So I can limit it to that. So that gives me already a lot less channels to deal with. Control values, we basically don't need any. So if you configure it like this, you get these channels is automatically locked to timeline. So if you play the timeline, this will automatically play. You will not see it here, but if you connect a MIDI out, you would then see the different channels to be played, and this goes here directly to well, directly you have to configure it here in the MIDI mapper. So you have to make a mapping, and I connected this MIDI synth, but can also just take the Microsoft, which sounds even more horrible. And that means you have now a MIDI device 1, and that's the one that you can select here. You send this to MIDI device 1, and that's the built-in Microsoft synthesizer. So now I have my channels here. I select only these 3 channels because I happen to know that only there is actually the action. Channel 1, 2, 3. There's the 3 voices of the piece. So my guess is that in a one voice piece, piano only, it would only be channel 1. So now I've got them here, and they look already quite touch designery. And in the next step, I select one of them, in this case channel 1. I do some math with it. I bundle it with an X, a generated X value for this amount of samples for the whole piece, which is basically the time axis or the frames, and will also later be the X axis of which the camera moves along. And I have a Z in which I can control the distance between the different layers of nodes. This all will be combined and then fed into a chop to sub, which creates a line object basically, with X value continuously this one, Z value no depth, and this is our nodes. And the problem I found is the -1 values here, because now it creates this. This is not really what's happening in my mind if you see a melody. My Python is not good enough, or my knowledge, to find out how I can get rid of this here on a chop level. But I'm sure with a bit of research that happens. So it would mean to find samples which are -0, delete them and fill them up with samples that would interpolate between the positions here. On the sub level, this is quite easy, but quite painful in terms of performance, because that's what I get out of here. All these points, I merge them together. I convert them into particles. I'm not sure if that's necessary, but that's something that I like to do. And here, obviously, I have all these notes which are actually never played here on the bottom. So I just deleted them with a volume, and then I get these these curves out of it later. Or here I just get points. That's why I converted them to particle, which I can render with a point sprite, in which then will give these dots that we saw. And another spot I get the same values. The same thing, but here I take just a part of them, so I trim them. And this, so there's like a few samples in between. That's as long as this line is that we then see. And the rest is driven by the timeline. So that's why these lines basically walk along from node to node and draw a trail behind them which is as wide as this trim. And what is quite fun is also to take that, to resample it, to make it much simpler, and then convert it into a NURBS curve. You get this much more, not so much these pointy notes, which looks very on and offish, which is not really what the music sounds, because it's on an organ, so every sound will overlap with every other sound. It's not just a 0-1 information. So this NURBS curve is actually much more what's going on in the song. Yeah, and that's the point at which I am. And this one is the other one, which basically just takes these three values into a job to stop, gives them to the axis, to the point attributes, and creates this kind of geometry, which then I connect here with an add sub and get this strange kind of geometry from the three voices. And a similar procedure is this one. Which has a similar approach of dealing with the channels. Here I pre-trim them because I made this on the laptop without docking station, so I couldn't handle so many channels. So I pre-trim it, so it's only 3000 frames that I'm dealing with. I split these up into, so I take the three voices coming on channel 1, 2, 3 and split them up into, split them up and call them RGB before merging them back together. So now they're not notes anymore, but they're RGB values, which then I shuffle. So I sequence every third channel, because here now comes always RGB, no, RRR. However, this does the right thing, I think, and makes a pure R channel, a G channel, and a B channel, which it shows how it's basically representing the piano notes. And then I have to shuffle these again, and this time by the, so I do all this, then I find out, okay, I have that many samples in a horizontal arrangement, so that would still be a line with RGB values, which would be like 21,000 pixels long, not a very nice image to print out. So what this shuffle does, it takes always, so it takes a square root from this number, which is 107, so I need 107 pixels on each side. So it takes this very long string, think of it as like an endless line of pixels with all the pixels that we have, and this one says split it up in pieces of 107. So I'll take the first line of our image will be the first 107 samples. The second will be the second 107. So basically our line is now folded into this image, and this is basically the result that we get. And with the same method, maybe we should turn off on the audio so we can hear it with the audio. In this one I just started doing it yesterday night, so I think it's not completely accurate yet. Although I think we have 2 of them playing now. No? Okay. Where is it? Here. No? Doch. Okay. So I'm still thinking you can kind of see what's going on. So for analysis, you could say, well, whenever it's white, it's actually using all the 3 voices at the same time, which rarely happens. It's not very often. Yeah, and another nice thing you can do with this approach is to not play with time, but to just make a complete picture of the piece. Is not happening yet. Yeah, and this is takes a bit of time, because there's a lot of data, but it will result in a image which is still smaller than 1024 by 1024, and which could be said to represent the whole piece in a data way. So basically it's the same process. Reads in all the channels, finds out which is which voice, gives them the RGB names, puts them back together, shuffles them so that the samples are arranged in time, shuffles them again to create the lines. This is the number of overall samples that we have. It's close to 1 million, and here I take the square root of that, and it creates this image, and I like it. I still have to figure out, so I still have to find out an automatic way to scan through the whole piece and really just find out which channels are used. I mean, now I know it's between 40 and 84, but in there's still a lot of unused channels, which I think is the reason for these black areas in here. Or I haven't quite wrapped my head around it yet. So last but not least, whatever. I want to mention that Markus Heckmann is going to come to town like Santa Claus. He's coming on the 14th of December. For those who don't know, Markus Heckmann is a very great touch designer programmer. He's working with derivative. He's the man behind things like Kammschnapper and Kantanmapper and many other cool functions that we all love. And he's going to come to Berlin to hold a workshop, and he's got guests. One of them is myself, and the other one is Daniel Del Fofo. He's not 100% sure, but it looks very good that he'll join us. And it's going to be 2 workshops. One is going to be on Friday the 14th of December. It's going to be an all-day workshop, and this is the 101 for beginners, which is really open for everyone who wants to look into creative coding, procedural, multimedia, blah blah, programming, VJing, scenography, performance art, you name it. And you don't have to have any knowledge before. This is really going down to the beginner. You need to bring your laptop, needs to be Touch Designer installed, and let us take care of the rest. So if we're very successful with you, you can immediately jump into the advanced class the next day. So I doubt that we can be that good. So the advanced class is looking at people who already work with Touch Designer, who already have understood stuff like instancing or Python linking, but want to go deeper into... Daniel confirmed. Yeah, great. Okay. So Daniel is there.
Marcus says it.
That's the big relief, because he really knows a lot of things. So one can definitely learn something from him. Yeah, and for this Sunday session, we are still open what advanced topics we should touch. So there's definitely some offerings we make. But if you're thinking about coming to the advanced class, there are still early bird tickets available. You can also drop us a line to say what you would like to learn about. And we will try our best to help you with that. Leaves me to thank Wieland very much for organizing already the 8th TouchBar, which is incredible. It's, writing history. And the audience here in the studio. Woo! Thank you for coming. And thank you for everybody who was watching. And let us know when you're in Berlin. There's always a TouchBar waiting for you.